Hello and welcome. We've been given a function z which is equivalent to x exponential to xy, and we have also been given values of x and y, that is x is equivalent to t squared and y is equivalent to t raised to power negative 1, and we've been asked to find the derivative of z with respect to t. So we're going to look at our formula. The derivative of z with respect to t will be given by the derivative of the function, that is this function, with respect to x multiplied by dx over dt, that is the derivative of this, plus the derivative of this function with respect to y multiplied by dy over dt. So I'm going to apply a product rule in finding the derivative of my function f with respect to x. That is because we have x here and x in the exponential. So that means I'm going to treat x as u and exponential 2xy as v. So the derivative of u, that is the derivative of x, is going to be 1. So 1 times v is going to be exponential 2xy. The reason I used this sign is because if I had to use x, it would look like this. So this one generally represents or denotes a binary operation. Could be positive or any other binary operation, but in this case it's multiplication, plus u, our u in this case is exponential 2xy multiplied by the derivative of v. So I'm sorry, u is x, so we have this x multiplied by the derivative of v is the derivative of this exponential. In deriving exponentials, we derive the power and multiply it by the coefficient of this exponential. So in this case, if we derive with respect to x, meaning we are treating y as a constant, the derivative to 2x is going to be 2. So this would be 2y because y is a constant. Then we multiply it by the exponential, so that is 2y exponential 2xy, then our x. So that's going to be the value for the derivative of the function with respect to x. We can simplify this by removing this binary operation to just have exponential 2xy plus 2y x exponential 2xy. Then we find the derivative of this function with respect to y, meaning we treat x as a constant. So if I treat x as a constant, I'll just have to find the derivative of this. So that is the derivative of 2y will just be 2x. So if I multiply this one with 2x, I'm going to have 2x squared. So that is 2x squared exponential 2xy. I then find the derivative of x with respect to t, that will give me 2t. The derivative of y with respect to t will give me negative 1 minus 1 will be negative 2. Then I multiply this negative with the coefficient, so I'll have negative 2t raised to power negative 2. So that means my dz over dt will be equivalent to df over dx by dx over dt. So if I multiply this with this, I'm going to get this. If I multiply this with this, I'm going to get this. So that has been simplified further, so that we have 2t exponential xy plus 2yx exponential 2xy. Negative and positive will give us negative, so we have negative 2t raised to power negative 2. This 2 is because of this, we said this times this, so we have this as negative 2 here, and then this one, x squared exponential 2xy. And then we need to do what we call total differentiation. That means we have to replace the values of x and the values of y with the given values. That is, we were given x to be t squared and y to be the inverse of t. So we're going to replace those values. So that is going to give us our dz over dt as x is t squared, y is t raised to power negative 1. You replace all these values. T inverse, y is t raised to power 2. So you're going to replace all those values. Then after replacing, you can now simplify by multiplying, for instance, t squared by t raised to power negative 1. Whenever we have the same variables, according to the rules of multiplication, we are going to add. That is 2 plus negative 1, which is the same as saying 2 minus 1. So we're going to have t raised to power 1, that is this one over here, exponential 2t raised to power 1. Then this one is going to be negative 1 plus 2, which is 1. So we're going to have 2, that is negative 1 plus 2 is going to give us 1. So that is going to be 2t. And then this one is represented in this. Then minus, we go to this. We first remove this. 2 by 2 will give us 4. Then since these are the same variables, we're going to say negative 2 plus 4. So negative 2 plus 4 is going to give us 2. And that one is going to be this. And then we have the last bit, which is this. 2 minus 1 is 1. Then this is going to be 2t. So we have exponential 2t. So we're going to rewrite this by factorizing out what is common. Or first let's first open the bracket to make it simpler. That is, this by this will be 2t exponential 2t plus 2 by 2 is 4. So you get this minus this. You notice that the variables in this are the same as the variables in this. So we're going to work this directly by saying 4 minus 2, which is going to give us 2t squared exponential 2t. And then we now have this and this. Can we have maybe something that can be factored out? We say 2 is common, t is also common, and exponential 2t is common. So if I factorize out 2t exponential 2t, I'll be left with, this it's gone, so I'll be left with 1. And then 2 is gone, 1 of the t is gone, so I'll be left with 1t. And exponential 2t is gone. So the inside part will just be 1 minus t. So this is the answer to the derivative of z with respect to t. Thank you so much for watching. Kindly don't forget to like, comment, and subscribe to my YouTube channel.